This example comes out of section 9.1, exploring rational functions using transformations. For this teaching example, I want to take a closer look at y equals 5 over x, just a somewhat random rational function to take a picture of. If you graph it on your graphing calculator, you'll get a sense of at least what the shape of it is. But I want to take an even closer look than that, so I want to do a table of values here. I'm going to start with very large negative numbers, see what happens with the function, and work my way all the way up to large positive numbers, and just to see what this graph actually is going to do. So I've chosen some numbers all the way down to negative 100 for x and all the way up to positive 100. If you put in a huge negative number, you get an answer very, very close to 0. This graph has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Its end behavior is basically it's going to approach 0 at this end, and it's going to approach 0 way over here at this end. The general shape of the curve is something like this. And, if we had some nice graph paper and plotted point by point by point, we could get an even nicer set of points there. But, if I even plot 1, for example, 1 comma 5 is one of the points in that table. You notice that when you put in x equals 0, you get undefined. That is where your vertical asymptote is located. It's your non-permissible value for x, the only value that x can't be. Domain and range would be important things for us to discuss here. The only thing that x can't be is 0. So if you just stated that and x is an element of all real numbers, that would be the domain. The range is actually the same idea. Y can't be 0. Otherwise, all real numbers are just fine. You could make, I left some spaces here in my table of values. If I put in, a really tiny little number like 0.0001 for x, you'll see that 5 divided by that is going to actually be a gigantic number, 50,000. And so, the smaller the number you put in for x, the larger number you get for y, and that's the behavior close to the asymptote here. The same would be true on the other side. If I did negative 0.0001, I'd get negative 50,000, and you can see that this thing also heads off infinitely in a negative direction. Another interesting thing to look at would be if you put in a number like 1,000,000 for x, your value of y ends up being 5 divided by 1,000,000, so 0.000005. Incredibly small, and you can make it as infinitely small as you want, both in the positive and in the negative direction. And so the same would be true over here. I'd have negative 0.00005, and so you can see why the graph looks like it does.